Thanks for asking. Oh, thank you. Is that my packet? Awesome, thanks. Okay, we're talking about money today. This is one of those days my students like to ask me sometimes, like, when am I ever going to use this in the real world? Well, I got an answer for you for this one. You're going to use this if you're not using this in your job, and many of you won't, you're going to use this in your personal life. Okay. And if you decide not to use this or understand this in your personal life, it's going to be used on you instead. Okay, because it turns out that the world of being an adult and having a job and paying bills, making investments and taking out loans and all of that stuff, all of the math for all of that stuff is exponential equations. Okay, so all of your banks, your credit card companies, this is the math that they're going to use to determine how much money you have and how much money you owe. Okay, these are the rules of the game of the adult financial world, and you want to understand the rules of the game, right? How else are you going to get ahead if you don't understand the rules of the game? So we're going to talk about some different types of investment today. So we'll look at the positive side of the money thing. Maybe we'll have a look at some borrowing later on. But for now, right now, let's talk about making money and making lots and lots of money. Sound good? All right. All right, so we're going to start on 320. And I would love for you to read the paragraph next to number 30, and I want you to take a couple notes on it for me. Oh, hang on, before we get pause on that for a second. There's something I want to do before we do this. Let's talk about percent increase and multipliers really quick. I just want to review this because we're going to need it. I'm just going to put this off to the side here. Could you guys make me a little table, percent increase or decrease and multiplier? So we're going to translate between these. I'm going to give you some percent increases and decreases. You're going to write the multiplier. I'll start by giving you some examples and see if this comes back to you. All right, let's see if you can do this. So we'll start with an example. We're going to increase by 2%. Does anybody know the multiplier I would use to accomplish an increase by 2%? What would it be? Close, 1.02. So if I want to increase by 2%, I'm going to multiply by 1.02. If I want to increase by 8%, see if you can write that down. Don't jot it out. Give everybody a chance to think about it. See if you can figure out what your multiplier would be if you're increasing by 8%. Hayden, do you mind saying it out loud? Perfect. 1.08. One more on your own. Increase by 27%. Got it. All right. Let's try some tricky ones on you. We're going to try decreasing by 4%. Anybody want to give this a shot? Decreasing by 4%. 0.4 is a good guess. 0.04 is a good guess, but not quite right. I think I heard it over here. Say it again. 0.96. 0.96. Now, what does 4 have to do with 0.96? How do we get it? So we start with 100 always, and we either add or subtract from 100, right? So in this case, I'm going down 4. So I think 100 minus 4 is 96, and that's where I get the 0.96 from. Let me have you try another one. Could you figure out a multiplier if we were decreasing by 9%? What would my multiplier be in this case? What do you got, Alex? 0.91. Excellent. One more. If I were going to decrease by 23%, what would my multiplier be? So 100 minus 23 is 77. So yeah, 0.77. Okay. We feeling okay about that? Okay, we're gonna end up using that today. All right, now we're gonna read number 30. Sorry to get you so excited about this. So here's what I want you to do. I would like for you to read this first paragraph, and I want you to take a couple notes in your notes about it. Any important words that you see here, any important numbers that you see here, I want you to take some notes in just right here on your notes that we're doing today. So right next to number 30 here. So just read that first paragraph to yourself. Take some important notes on there. If you finish reading and you want to go ahead and read the next couple questions, that's fine. We're going to do some of them we're going to skip. The paragraph right next to number 30 starts with suppose you have. Okay. Get my attention at the end of class. All right. There's a couple words I want to talk about here. What does the word invest mean? Anybody know? What do you think? Okay. So it has to do with money, and you're putting money into something, you said like shares of a company. That'd be one way that you could do investments. That's great. What else? Okay, now that's key. That was a perfect description there. So we got some great examples, putting monies into shares of stocks and that kind of stuff. But the word invest in general means not only are you saving money, not only are you putting in the bank and hoping it's going to be there later, but you're putting money away and you're expecting to pull more money out of it later. Okay. There's this thing called interest. When we're talking about interest with money, interest is money that they pay you. Okay, so this is for real. I told my first period class this, and they didn't believe me. If you go to a bank and you put money into your bank account, your bank will pay you money just for having your money in the bank account. And that money, extra money that they give you is called interest. It almost seems like it'd be a scam, right? But it's not. Okay, they will give you extra money. So when we invest money, we're putting money someplace like in an account or in stocks, like you were saying. But the key is that we expect to end up with more money after the fact. Okay, so you're getting paid basically for waiting around, and that's what we're going to talk about today. How much money are we investing in this problem number 30? Would you guys write down? $1,000? And could you tell me, there were two types of interest that we were gonna talk about on this? What did you read about? Okay, so our interest is 8%, and there were two types of interest, and you said one of them was simple interest, and the other one was compound interest. And my big goal for you guys today is to understand how the concept of interest works, and especially to understand the difference between simple interest and compound interest. One of these is better than the other by a long shot. You think it's compound? Does anybody know the difference between them before we even get started? Okay, so you're already thinking add versus multiply, which I love, because we talked about both of those things in our homework. Let's go ahead and do this. So we're gonna do simple and compound. I don't want you to worry too much about the fact that it's saying a bond with simple interest. A bond is just like, you can think of it like a bank account. Yeah. What it is in actuality, it's a piece of paper, like a certificate that you buy, and then later on you sell it, and when you sell it back, you get more money for it than you bought it for. or less, hopefully more. All right, so I want us, and this is going to take a minute. Can you guys take a minute and copy down the table for me for each of these? So for each of them, we have a table that has number of years and then the important one, which is money. Zero. There. And all this is in your book, so if my handwriting is too small or messy for you to read, feel free to refer to the book. All right. As you're wrapping up, and I can already tell from some of the comments I've heard that you're thinking about this, but as you're wrapping up, I want you to think about patterns. If this were a sequence, what would my pattern be? How am I going from one to the next for both situations? I'm not interested in answers right now. I just want you to start thinking about it. Question? This right here? Yeah, this is 1,160. All right, before we get into patterns and how things are changing, here's my initial question. If you were going to look at this right now and you had to choose between these two different investment options, which one would you choose? You'd choose compound? Why? It's more money. Definitely after 3 years, we've made more money, right? Look at those two numbers. It's not really that much though, is it? It's not much of a difference. In fact, after 1 year, is there any difference at all? It's the exact same. If you're only going to do it for 1 year, it wouldn't matter which one you chose. But once you start getting into 2 years, like this is, I mean, it's $6 more than this one. Are there taxes on them? That's a good question. We're not going to get into taxes today. Sometimes, yeah, so that's a good point. Sometimes when you take money out of an investment, you have to pay taxes on it. There's some ways to get around that, like legal and not so legal ways to get around that. No, we're not going to do tax evasion in here. Okay, so we're actually not going to bring taxes into play at all because that complicates things. So let's just talk about the growth of our money. So we're leaning towards compound. It's a little bit more, not that impressive, but we're making a little bit more money. All right, let's talk pattern. Question before we go on? Comment? Okay. Cool. You're a little bit ahead of us. Let us catch up to you here. What's my pattern here? Am I adding, subtracting, multiplying? Adding how much? We're doing plus 80 each time. All right, so if you know that, then you should be able to figure out what we have after 4 years. So take 1240, add 80 to it. You're going to want a calculator if you don't have one out. Make sure you grab one or share one with a friend. 1320, if I'm not mistaken. How about this second one? What was our pattern over here? What's the pattern over here? Adding, subtracting, multiplying? What do you think? 1.08. How'd you get that 1.08? Okay. Good. I like that. So you were kind of doing a little guess and checking, but using your your previous guesses to kind of narrow it down? You were using the cheat code where you did the second one divided by the first one. That works also. It was definitely our multiplier is 1.08. Is that surprising to you? Would that be an increase or a decrease? Think about the review that we did up here a second ago. Would that be an increase or a decrease? It's an increase by 8%, right? That's what they told us in the problem. It was going to be 8%. So I'm not super surprised that we're getting a 1.08 multiplier, right? Because they told us 8% increase. Cool. Go ahead and multiply to figure out what your fourth one is there. So I'm going to do 1259.71 times 1. I'm just going to round to my nearest cent because that's what they've been doing. $1,360.49. So I think we've caught up to you. Hayden a moment ago was comparing these two, and that's $40 difference after 4 years. Now, is $40 a good amount to earn after 4 years? It's not a whole lot, right? All right. So one of these is a linear function and one of them is exponential. Anybody want to take a guess which is which? You think the simple is linear? So if I were to graph this, I'm going to see a straight line. Yeah, you're right. It would be linear. Can I get you guys to write that word down? This is a linear function. Linear function. It is kind of a big word. And the reason we know it's a linear function because we're adding or subtracting. Our pattern is adding or subtracting. And what's awesome about linear functions is we spent a whole bunch of time back in first semester writing equations for them. Remember y equals mx plus b? So I'm going to fill some numbers in here. Just as a quick reminder, what was the number in front of the x? Was that our starting value or our change? That was the change. And then what was the number after that's not multiplied by the x? That's our starting value. Can you look at our example here, this table, and identify your starting value? What is it? 1,000, yes. We start at 0 years, it's $1,000. So this would be plus 1,000. And can you look at what we've done with that table and tell me what your change is? Change is 80, positive 80. So we've got a model now, we've got an equation for this linear function. And that's old stuff. We've been doing that for months and months now. The new thing that we just kind of started on was exponential functions. And I'd love for you to write this word down. So you've got it right in your notes next to a table, and we're about to write an equation too. Exponential functions. If you can't remember what the equation of an exponential function looks like, most of you took some really good notes on Monday. Mine looked like this. Do you guys remember taking these notes in your blue packet? So exponential functions will have an equation that looks like this. It's got an exponent in it. That's why it's called an exponential function. And let's draw some arrows and label these spots too. Are you guys putting these words into your notes so that you've got something that you can look back at later on? And some of you are going to choose to maybe transfer some of these into your packet at some point too. Where did the start value go for an exponential function? Was it out front or inside the parentheses? Start value? Here on the left? Yep, that's our start value. And what goes in the parentheses is our change, but we're going to be more specific. This is our multiplier. So put some numbers in there for me, please. And then I want to do one more thing before we start talking about money again. We're trying to make some connections here. Can you guys make me a rough sketch? Draw yourself a little XY axis. Make me a rough sketch of what each of these graphs would look like. You told me this was a linear function, so what should the shape be? Should it be curved or should it be a straight line? Linear means straight line, right? So it should be a straight line. Is it going to be increasing, a line going uphill like this, or is it going to be decreasing? It's going to be increasing. So our graph would be a straight line that would be going up like that. An exponential function, we played around with graphs of exponential functions on, when was that? Thursday of last week? You've got some examples in your packet, hopefully. This is the one that's curved. Look at this multiplier right here. Is this multiplier bigger than 1 or less than 1? Bigger than 1. What's that tell us about the shape of the graph? Yeah, so it's going to be increasing. It's going to be curving upwards because the multiplier is bigger than 1. So we're going to see a graph that looks like that. All right, now it's time to get down to the real information here. You guys all agreed that the compound interest was going to earn you more money, right? But you weren't super impressed with how much more. Okay, but I want to show you something important about exponential functions and especially about compound interest. And this concept that I'm going to try my very best to convey to you is probably one of the most important things you'll learn in high school. I'm being dead serious about this. Okay, so check it out. I want us to figure out, we've already figured out for the first 4 years. I want to figure out how much each is going to be worth after 10 years. And I want to figure out how much each is going to be worth after 25 years. So we could go back to our table and just do plus 80 a whole bunch of times until we got to row 10, but that would take forever. Why would we want to do that? There's got to be a faster way, right? How could we figure out how much our account's worth after 10 years? Help me out here. What could I use that we've already put down here on our paper? I see a couple people typing stuff into their calculator, so I know you know the answer to this question. How would we do it? What about this thing? What was the point of writing this equation here? Yeah, this is X, right? This is the number of years is X. So why don't we put 10 into this equation? Right? We'll plug 10 into this equation and that'll tell us how much money we're going to have. So I just need to type this into my equation or into my calculator. I just need to replace the X with a 10. So I'm going to go 80. It was times X. I'm going to make it times 10 and then plus 1,000. Which is $1,800. Hey, that's how much you would have in your account in 10 years. You'd have $1,800. That's pretty good. That's not bad considering you only started out with $1,000. You just got $800 worth of money. You didn't have to do anything but just sit there and wait for it. That's not bad. After 25 years, let's do the same thing. I'll do 80 times 25 and then plus 1,000. $3,000. Hey, that's that. If we wait 25 years, we basically get $2,000 for free. We don't have to work any harder for it. It's just sitting there in an account earning interest. Let's do the same thing for the exponential function, okay? This time we're going to have to put the 10 and the 25 in the X here. So we need to know how to do an exponent in our calculator. What you want to look for in your calculator is a button that looks like a little upside down V. Some of the calculators have like an AB that looks like an exponent. You'll have to fiddle around with it. Let me know if you need any help figuring out how to put an exponent in. Give me just a moment. I'll be right with you. What's up? Can I grab it? Do you mind if I put it up on the screen so other people can see? Is that okay? So I'm going to try and figure out how to do it on this calculator. They're all a little bit different. So I'm looking for something that looks like an exponent. This one here, that does look like one, but it's got an E in it. So you'll learn all about E in algebra 2. I think it is, oh, it's right here. See this one that's got a little X and a Y? It's the actual button. So I'm guessing, I'm going to try 2 to the third because I know the answer should be 8. So I'm going to type 2, this button, 3 equals, okay, so that's what you do. So what you need to do is, I think first you want to type in the 1.08 to the 10. And then this button 10 and hit equals, and then come back and do times 1000. And that gets us the same answer. Yep. Thanks for that. Yeah, so 1.08 exponent button 25 equals, and then do times 1000. I know. 27,000 seems too big. Now, I want you to look at those numbers and compare them. A moment ago, you guys, we agreed that we were going to go with the compound interest because it made us a little bit more money, but you weren't super impressed. You're like, it's only 40 bucks more. That's if we wait 4 years. If we wait 25 years, I'd say that's significantly more, isn't it? I would be kicking myself if I went with this one and then my buddy went with this one. I mean, that's over twice as much. And keep in mind, even for both of these are great because you only ever put $1,000 into it. All that extra money is interest, but this one got a lot more interest than this. Right? So we'll look at some bigger money examples here in a second, but I want to talk about one more here, okay? Let's say you decide to put this away for your retirement. So I want you guys to think about, first of all, how old are you going to be when you retire? Do you need someone? 58? Oh, really? Congratulations. How old do you guys think? How old are people when they retire? Retirement's when you stop working. You got enough money saved up that you can just stop working. 80? I hope it's not 80. 20s? What do you think? 65? 65 is pretty close to the average age, I think, in the United States right now. It is trending upwards at the moment, so it could be higher than that by the time you guys get there. 64. Okay. Hey guys, don't let me lose you here. So when you retire, let's say you retire at 64 years old, okay? And let's say you made this investment now. How old are you guys? 15? Most of us 15 years old. How many years is it between now and when you're 64 years old? Can someone do that math for me? How many years are you going to have to wait until you're 64? How? One more time. 49? 49 years. Can you guys figure out how much this thing's going to be worth if we set it away for 49 years? Let's say we decide to wait for it till we retire. So plug that back into your calculator, but put 49 in for your exponent. That's a lot of money. So question is this just money that's sitting in your bank account? Yeah, it is. So you put that $1,000 in and you had to wait 49 years. Basically, you're getting paid to wait. You can't touch the money. You can't actually use it. You'll pull it all out at the same time when you hit that number, and then you'll do something with it. Spend it on something, or else you'll put it into another account where you can access and use it, like for groceries and that kind of stuff. So that's a great question. A lot of times when you withdraw the money from your account, that's when you pay taxes. There are some ways that you can get around that. So there are certain types of investment accounts that are protected so you don't pay taxes on the back end of them. Like IRAs and that kind of stuff. Yeah, there are some certain types of retirement accounts, and you'll learn all about that. But let's not get too heavy into taxes, but that does become an important thing because you do end up paying some taxes. But keep in mind, how much money did you put into this account? $1,000, and you're getting out 43,000. Now, okay, so guys, I need you to pay attention here, okay? Because this next part is not in the book, and you don't even need to write anything down here, but I want you to see this, okay? So it can get more complicated than this because most of the time people don't just put $1,000 into a bank account and let it sit there. What do people do when they're saving for retirement? They've got some money, they put it in the account, but then what are you going to do every month also? You're going to put a little bit more in. Hey guys, can I get your attention? I don't want you to miss this, okay? I appreciate you guys are playing around with the math, but watch this, okay? So I've got a program on my calculator that lets me deal with this. The math gets really complicated when you're also putting money in. So let me show you how this works. So we're going to say, I'm going to go back to 25 years. No, let's stick with 49. Let's stick with 49. 49 years times 12. So this n needs to be a number of months. So this 588 is going to be the number of months that I'm going to wait. That's our 49 years, okay? Interest rate's 8%. Present value, I'm going to put $1,000 in to start with. That's PV. And then my payment, I got 50 in here. How much money do you think would be a reasonable amount of money for you to stick into an account every month? 500? You're going to put 500 in every month? That's a lot of money. I mean, at some point in your career, you'll probably be making enough money to do that, but 500 is quite a bit to start off with. You want to do 100? I'm hearing anywhere from 50 to like 200. Okay, let's start with 100. Okay, let's just see. If I were to put $100 a month in for 49 years, starting with $1,000, let's see what we're going to have at the end. Anybody want to make a guess on this? Well, let's just see. You would have $780,000, almost $781,000. That's $750,000 every month for 49 years on top of the $1,000 that you put in, right? So I want to show you this. You're doing $100 every month times 12 months in a year times 49 years. So you're going to end up putting $58,000 into it, right? Plus the 1,000 that you already put in at the beginning, right? So essentially you just put 60 grand of your own money into it. That's how much you put into it. But you're going to get out of it $780,000. That's a lot. And that's a wonderful point. So you might start off at the beginning putting $100 per month in, but as your income increases, as you get better jobs, as you get those raises, you also start putting more money into it. So later on in your career, you're putting more money into it. But here's the big thing that this is the reason I want you guys to pay attention to this, because I made a very costly mistake when I was your age, not too much older than you guys. I got out of college and I had all kinds of people around me telling me, when you get out of college, you should start investing for retirement right away. And I was like, dude, I'm 22 years old. Retirement is so far away. I'm not going to even think about that. Talk to me when I turn 40 and I'll start thinking about it. Okay. Luckily, it was only about 10 years later when I hit my mid 30s that I actually started, but I waited 10 years before I started. Okay. Imagine that we did this same thing, but instead of doing 49 years, I only did 39 years. Okay, I want you to see what that 10 years cost me. All right, so I'm going to do 39 years instead. Keep in mind, if I did 49 years, I'd have $780,000. If I only do 39 years, that drops to 343. That's more than half. That 10 years that I waited cost me about $400,000. Isn't that crazy? So don't make the mistake that I did. When you guys get out of college and you start getting that paycheck, okay? And for those of you who are just going to go straight into the workplace, same thing. When you start getting that real deal adult paycheck kind of money, I want you to start right away and think about, even if it's only $50 a month or $20 a month, if that's all you can put away at the beginning, the earlier you start, the more you're going to have at the end. Even a small delay like 10 years, in the grand scheme of things, that's 10 years over 50 years, could cost you a whole lot of money. Okay, ask me some questions. Okay. Right. Okay. By the end of it, we could see. So the trouble with this is the math that we're doing here is kind of based on a long-term investment. You're dealing with something that's a little bit shorter term. Till you're out of college. So how many years are you going to have the job? Would you guess? You're 15 now, so out of college, probably be 22. So say 7 years. So 7 times 12. Okay. Interest rate 8% right now is a little much for an interest rate. So let's put that at 5. Do you have some money that you've already saved up right now? Okay, you don't mind telling us that? Okay. All right. Thank you. And how much are you thinking about putting away every $250 every 2 weeks? So that would be $500 a month, right? So you're putting $500 a month away. So let's see how much you would have after 7 years. You have about $50,000 saved up. So it's gonna be in the neighborhood, right? We're estimating here. But that's not bad. Out of college with 50,000. I mean, 50,000 is a nice down payment for a home. And or it will help with some for your tuition and books and that kind of stuff. Other questions? Yeah. So you're not going to get this kind of interest from a savings account. Savings account have interest rates that are more like 0.02%. Okay, so if you put it in a savings account, you're going to earn a lot less money. Well, I guess that's not that much less. The thing is, if you were just to 250 or 500 a month for, you said 7 years, 7 times 12 times 500, you're going to be putting in 42,000. Okay, so but you're going to get out 50,000. So you're going to basically be getting an extra $8,000 for investing it instead of just sticking in a bank account. Yep. Question. In there, like an actual, like any of those accounts that you make it taxable. Okay. And I don't know. How do you know all this tax law? That's pretty impressive. Okay, that's cool. So there are ways that you can invest it at this point until you're not a minor. You might need to have your folks invest it for you in one of their accounts. So, and then, you just kind of keep track, and you'll have to make sure that not just how much you put in, but how much it's worth at the end based off of the interest that they were earning. But the big thing is when you are 18 or you're 22 or whenever you really start that first career, they'll talk about like direct deposit. And one of the smart things that I've done now is when I get my paycheck, I get it direct deposited, but I have 2 different accounts. I have one that's like, goes into this account. I use that for my spending money, for my bills and everything else. And then the rest of it, and it's a percentage, goes over into this other account. And at the end of each year, I take that money and I stick it into my long-term investments, right? So that way, when I get my paycheck, I don't even miss it because it's getting taken out before I even get my paycheck. Yeah. So if you get in the habit of doing that right away and you do it as a percentage, I heard you say 10% at the beginning of class, that's the smart way, because then as your income increases, the amount that you're putting away is also increasing, but you never miss it because you're always still getting your, you know, that just the rest of it that's not getting deducted out. So anyways, I'm super happy that you guys were willing to pay attention to my long ramble. I hope that you guys learned something about a little bit about money. It is kind of a game. I'm going to be honest with you. The financial system in our society, it's kind of a big game. And like any game, the people who know the rules the best are the people who are going to be able to do the best. So you want to make sure you keep yourself educated on this. We have a couple courses at the high school that are all about this. There's a financial algebra course that's starting next year. You guys would be eligible for that if you're a freshman year, junior year, if you're a sophomore year, senior year. And then there's also personal finance course that's a really good one too that'll get into a lot of this stuff a lot more. But it's amazing how much you can make if you know the rules, or it's amazing how much you can throw away if you make silly mistakes like I did when I decided to wait that 10 years. All right. So we got some time for you guys to work on our assignments. Go ahead and put this up here. We're going to do 35 to 41, but please skip 39. I would love for you guys to get started on this right away. I want us to use, let's see, how much time do we have left? About 10 minutes before we start packing up. Yeah, so let's give it a solid 10 minutes and see if you can get done with at least number 35 and maybe 36 as well. I'll be around to answer questions. I'll bring my calculator program with me if you want me to try punching any other numbers in. I'd be happy to do that. Okay, I'll be around with my stamper in a minute.